Hi student, today I want to continue the SPM module question for second discussion. So I will show you some of the SPM question and also I will discuss what the question about that and also the answer. Okay, we start now. Okay, now we continue with the last one. Last one we discussed also SPM. Now I continue with the chapter 3. There's a Archimedes principle. Okay, let's see the question 6. This one is a SPM 2013. Okay, they show a diagram. There's one of the log. They are float on the surface of the river water. So remember, when something floating, then we know the situation is buoyant force equal to the weight of liquid display. They also equal to the weight of the object. Okay, so this one you need to know when the object is floating. So from here we answer question A. Name one force that's acting on the load. Okay, so from here you can say about the weight. Weight is acting on the load. You also can say about the buoyant force because there's a in the water. So from here you answer either buoyant force, either weight. So give one reason why the log is float. Okay, the situation, the log can be floating. So we can say buoyant force equal to the weight. So that's why they can float. If the weight more than buoyant force, mean the object already is sinking. Okay, so now I give the reason. Buoyant force equal to the weight of log. Okay, then we're going to see the C calculation. Okay, the mass of the log is 1200 kg and the density is 1000. Okay, calculate the volume of the water displayed by the log. So from here, because buoyant force equal to the weight, so we know the weight is how many. Okay, weight you just 1200 multiply with the 10. Okay, after that, buoyant force, the equation is a V rho G. So V we do know because the question they ask. Rho there's a 1000, then G is a 10. So finally we can find what is the volume. Okay, let's see here. Mg equal V rho G. So Mg is a 1200. Actually there's multiply with the G, is it? G and G actually we can cancel. We no need to multiply already. So M is a mass, then V we do know, then the rho is 1000. So finally I get the volume should be 1.3. Remember the unit for the volume is a meter cube. Okay, now we go to D. What happened to the volume of the water display when the log is flow in the sea water? So the keyword is a sea water. Sea water, the density should be higher. If the density become higher, means the whole thing, because you equal to mg, is it? Mg cannot change one. So if I say the rho become up, okay, density become higher, your volume display must be less. Is it? Because this one should be constant number. One become up, another one should be down. So they say what happened for the volume display? So the volume display must be less. Okay, because the density become higher already. So the answer here decreases. Okay, so this one is a simple question. Now we continue with another question about the Archimedes principle. There's a 2009. Okay, diagram 5.1 and 5.2. They show about the spring balance supporting the metal block in the two situations. Okay, now the metal block is identical. Okay, the compression balance in the 5.1 and 5.2, they show the reading of the weight of an empty beaker and also the weight of the beaker filled with the water respectively. So you see the diagram, both also using spring balance, hanging the metal block. Both metal block is the same. Okay, now the water, before you put in, okay, now you need to see what is the weight of the beaker. The beaker just 1 Newton. Okay, now you put in whole metal block in the water. Now you find it, they become 3 Newton. Actually, the weight of display by the block is how many? There's a 2 Newton only, because you need to minus the beaker weight. Okay, so from here the beaker, they also identical. Okay, so now I know actual is 8 Newton. This one we call apparent weight. Okay, apparent weight. Then all the weight of the liquid display we can say there is a buoyant force. So from here, I can conclude 8 Newton actual weight, 6 Newton apparent weight. Okay, buoyant force is how many? 8 minus 6. There's a 2 Newton. Okay, so after you understand the question, then we go and see what they want to ask. Okay, now the first one, what's the meaning of the weight? The weight must be related with the gravitational force. Okay, the force to pull you. So now you can see the answer. There's a gravitational force acts on the object. So there's a weight. Okay, B. What's the difference between the spring balance reading in the diagram 5.1 and 5.2? So we find what is the difference. One is a 8, another one is a 6. So the difference must be 2 Newton. Okay, name the force that's represented by the reading in B1. That means the 2 Newton actually is what? That one is actually buoyant force. Okay, what's the reading of the compression balance in the diagram 5.2? So we get it, the reading is 2 Newton. Okay, so from here, we continue with the number 2. Name the physical quantities that's represented by the reading you mentioned in the C1. That one reading 2 Newton actually is what? There's a buoyant force, or you can say there's a weight of water display. Okay, so that means we ignore the beaker lah, because we just find the physical quantity represented by 2 Newton. So you can say buoyant force, you can say there's a weight of water display. Okay, related, the answer B2 and C2. So if the question asks related B2 and C2, so you cannot write the same answer. Okay, so if both also buoyant force, how to compare? So that means the B2 you write buoyant force, and the C2 you write weight of water display. Okay, now we relate. The relay must be equal. So from here I can say buoyant force equal to weight of liquid display. Okay, now last one, they ask you need to name the physics principle. So the physics principle, there is Archimedes principle. Make sure you know how to spelling. Okay, when they're just talking about principle, you cannot say buoyant force, you cannot say weight or liquid display. You must find the phenomena got principle. So this one is a Archimedes principle. Okay, E. What happened to the spring balance reading in a 5.2 when the metal block is immersed deeper into the water? So you find it, the whole metal block already in the water already, is it? Now I go deeper some more. Actually, there's no changes because your whole volume already in. So from here I find it, there's unchanged. Okay, then we go to number 8. Also 2003. Okay, they show you 3 figures. Okay, figure A, the first one, they're hanging in the A. So that means understood 10 Newton is the actual weight. Okay, now they put the halfway. Halfway, partially, they're in the water, they show 8 Newton. So that means I know this one situation, the buoyant force is 2 Newton. Okay, now the whole block go in. So becomes 7 Newton. So that means now the buoyant force is how many? The buoyant force is a 3 Newton. Okay, so this one is what we understand the diagram. Okay, what question they ask we don't know. So we understand first. Okay, now they need to compare. Compare the reading of the spring balance A and also B. Sure, the A is bigger lah. So we answer. Okay, A is bigger than the B. So remember, don't write the symbol like this. You need to write its full sentence. Okay, maybe they will cut your marks. Okay, now we go to number 2. Can you name about the 3 forces that acting on the K when it's partially or totally in the water? So the first one we know sure got weight. Any object sure got weight. Okay, number 2, because you put inside the water, then you sure got buoyant force. Okay, one more force, because they said 3 forces. Okay, can you see the string from the spring balance? They go to hanging the block. So that one we call tension. Okay, tension is one of the force. So from here, we got 3 forces. Buoyant force, weight, and also tension. Okay, now you need to explain, or you need to state about the relationship for the force you mentioned just now. Okay, now we need to see the direction. Weight always go down. Okay, buoyant force is up, acting upwards. How about the tension? The tension also acting upwards. If the tension acting downwards, mean the whole object already fall down. Okay, so the tension also go up. So from here, the object now is stationary. So we say this situation, there's a balance. There's an equilibrium. So that means weight will equal to the buoyant force go up and also tension go up. Okay, so that means I can say buoyant force plus tension that will equal to the weight of the object. Okay, now we write the answer. Buoyant force plus tension, that's equal to the weight. Okay, because of 2 marks. 2 marks, that means you need to add one more sentence. Why I say like this? Because this one situation, we call it is a equilibrium. Okay, force in equilibrium. So now they ask principle. Okay, principle, you cannot say force in equilibrium because force in equilibrium just one of the concept. Okay, now the principle still the same. There's the Archimedes principle. Okay, let's see the E. What will happen to the reading of the spring balance in the figure C if the water is replaced by the salt solution? Again, salt solution means density higher, just like the sea water. So when the density become higher, because this one situation not equal, weight cannot equal to the buoyant force. So from here we can say when the density increasing, that means the whole weight of water display also increases it. So from here I can find it. The reading of the spring balance that will decreases because your buoyant force increase. Buoyant force increase means that acting upwards more already. So your apparent weight will show the small reading. So from here the answer is decreases. Okay, give one reason. Now we give the reason. Salt solution means the density higher. Okay, buoyant force increases due to the high density of salt solution. Okay, because you need to know buoyant force, the formula is a V rho G. Okay, V rho G, that means when the rho just increase, that means the whole thing also increase. Okay, then we go to the question number 9. Okay, they show about a submarine floating stationary. So this one is a keyword. Floating stationary on the surface of the sea. So when they say floating, then you must related buoyant force equal to the weight of liquid display. They also equal to the weight of the object. Okay, now name the principle. So the principle is the same. Archimedes principle. Okay, now is calculation. The mass of the submarine, there's a 1.5 times 10 power of 7. So that means they give you the mass, means you know the weight already. Density of the seawater also given. Okay, first one, calculate the buoyant force act to the submarine. So buoyant force, if you want to calculate, you must using V rho G, is it? For this one situation, we do know what is a V. How many volume display, we do know. So we can using the weight to represent because there's a floating. So I can write buoyant force equal V rho G. Okay, so from here the VB, the FB, sorry, there's a buoyant force. Okay, 1.5, that's a weight. Okay, we get this one V rho G become mg. So from here I can get 1.5 times 10 power of 7 multiplied with the 10. Actually this one not using V rho G. That's using mg to calculate the V rho G. So from here I get it. Buoyant force is a 1.5 times 10 power of 8 Newton. Okay, next. The question sure will ask you the volume. So from here I need to find by using V rho G. So 1.5 times 10 power of 8 will equal to the V rho G. So you divide the rho and divide by the G, then you find what's the volume. Okay, so 1.5 times 10 by 8. V is here, then this one is a rho, then this one is a 10. 10 is a G. Finally, I get it. The volume display is 1.46 times 10 power of 4 meter cube. Okay, C. When the water is filled into the ballast tank, the submarine will submerge into the sea. Give one reason why they submerge. Something submerged means sinking. Sinking means the weight of the object sure bigger than buoyant force. So that's why they can submerge into the water or into the sea. So this one citation, we must know when you add the ballast tank, what's the function for ballast tank? Ballast tank, the function is to fill in the water. When they fill in full of the water, you find it, they will increase the weight. When the weight just increase, that means they're bigger than the buoyant force, they can sink deeper. Okay, so from here, okay, weight greater than buoyant force. So that's why they will submerge into the sea. For this one question, just 1 mark. So you just answer like this. If 2 marks, that means you must say function for ballast tank. Okay, when you add the water into ballast tank, the weight is greater than buoyant force. Okay, then finally, they will sink into the deeper. Okay, now we go to question number 5. A, they show about a piece of paper. Okay, they're hanging from the resource stand. When the air flow from the nozzle of the air pump, now the paper, they changes the position. Okay, let's see the diagram. Okay, this one is a diagram. This one is before. Okay, A is before. This one is a B after the air come out from the nozzle. So you need to understand the air come out from the nozzle means the air move faster. Nozzle, you know the hole is very small one. Okay, when it just come out the gas, so that means upper part, the air is move fast. Lower part, the air is normal. So now we need to compare the position. Okay, what you can see here, the position, I just can see the figure B, the paper lift up. This one is down, is it? Now they lift up. So I just answer, paper in figure B is pushed upwards. Okay, now F is a force that causes the paper that changes the position. So in the box X, this one is a box X, on the figure B, you need to indicate and also label the direction of that X on the paper. So from here you find it, how the arrow you need to draw, up or down. When the force acting to the paper, they will lift up. So the arrow sure up because you're acting. The force push, then the paper will up. Okay, now you need to explain how the F is produced. How come this one force can produce? So this one you must relate it to the Bernoulli principle. So you must say when the nozzle produce the gas move in high speed. Okay, if follow the Bernoulli principle, high speed means now they can create low pressure above the paper. So they create low pressure above the paper. That means at the below of the paper, that one is a normal atmospheric pressure. They will become bigger. Compare these two lah. So we cannot create the high pressure. We just create one part become low pressure. So that means another pressure sure become higher. Now the higher pressure, they will push. Okay, they will produce the force to push the paper up. So this one is how to answer question C. Okay, now we're going to see one by one. Air flow at high speed above the paper. So they will create low pressure. So this one is the first sentence. So you must say different of the pressure. Different of the pressure means up and down. They will produce a resultant force acting upwards. So that's the arrow what you draw, that one is a resultant force. Okay, D1, we need to compare the position of the paper in figure B. How does the position of the paper change when the air flow faster? Air flow faster means the pressure become lower and lower. If the pressure become lower and lower, means your resultant force is very large. You can push the paper more upwards. So they will go more higher. Give one reason. So we're talking about Bernoulli principle, the concept lah. Okay, greater force produced. Okay, if the question is 2 marks, you need to explain how come the greater force produced. You must say high speed, lowest pressure. So greater force produced. Just 1 mark, you just can say resultant force become higher. Also can. Okay, now they ask what is the principle? So from here, the principle is a Bernoulli principle. Okay, F. Name one piece of apparatus in the school lab. This one question is always with us. So remember, what apparatus we using Bernoulli principle? There's a Bunsen burner. Okay, now we go to question 11, 2017. Okay, diagram 2, they show about the cross-sectional of the spoiler, which is attached to reacting the car. Okay, now you can see the, sorry, not reacting, that's a racing car. Okay, now the aerofoil shape and also the spoiler, they produce a downward force when the air flow through it. Okay, they're just opposite direction with the aerofoil. Okay, aerofoil is up curve, down flat. This one is reverse. So reverse, we're going to see what's the function. Okay, name the principle. Again, the principle is a Bernoulli principle. Okay, let's see the B. The upper surface of the spoiler 0.25. The pressure act to the upper surface of the spoiler 1500 Pascal. Then the pressure at the lower surface is 500. So that means upper part the pressure become higher. Okay, they will push. Okay, push, then after that they will go downwards. Okay, now we need to count the difference of the pressure between upper and lower. So we just minus 1500 minus 500. There's a difference with the 1000 Pascal. So the downward force acting to the spoiler due to difference in the pressure to be. So we need to find out what is the force. So remember the force we're using pressure to calculate the force. P equal F over A because the question provides the surface area. So we just apply, this one is the pressure, then force over area. So I know the force acting downward is a 250 Newton. Give one reason why downward force is needed for the racing car. Okay, so downward force because you want to make the whole car the more stable on the road, do not lift up. So this one function should be, they want to increase the stability for the car on the ground. Okay, this one different with the aeroplane. Aeroplane want to lift up. So that means you find it, the aerofoil shape is up become curve. This one, they want to make it become more stable on the ground. So you need to reverse the aerofoil shape. Okay, then we go to question 1006. This one is show about the situation. One, a student, they go to blow the paper before and after they blow. 20.2, they show about the situation for the canopy before the lorry move and also the lorry high speed. So before lorry move means no air. When they move already, that means you got air pass, is it? So you find the canopy, they will up already. So this one also same. Before the student go to blow, you find it the paper is go down. When they just blow, the paper will lift up. Okay, so from here, first one, what means by speed? So what means by speed means rate of change of the distance. So see the answer? Okay, don't show the formula because the question asks about the meaning. So better you write in words. B. Based on 20.1, 20.2 diagram, you need to state two similarity. Okay, what you can see two similarity. First one, I can see, okay, the paper and also canopy, they will lift up when the air start to move. Okay, so before that, before the air start to move, paper and canopy is never lift up. So this one is what I can see lah. So we check the answer, is it like this or not? Okay, if no air movement, the paper and canopy will not lift up. So paper and canopy will lift up when the air move. So this one is what we can observe from the diagram. Now you need to compare the air pressure above and below the paper when the air is blown. So above sure become low pressure because high speed you go to blow. Down become higher pressure. So from here I know the pressure above less than below. Okay, relate the speed of the air and pressure. Okay, so from here speed increase, pressure decreases. So that one is a Bernoulli principle. high speed A, low pressure region. So the principle, Bernoulli principle. So diagram 20.3, they show about the instrument they use to measure the speed of the A. Okay, let's see what instrument. Okay, first one, before A flow, they put the red water. Okay, after that, this one is before you go to flow. Okay, they find it the same level. Same level means the pressure should be the same. Okay, now they start to flow. Okay, when they start to flow, can you see this part? Okay, the part P. The tube diameter is smaller. When the tube diameter becomes smaller, the A want to pass through, they will in high speed. Example is just now question, nozzle. Remember the nozzle, the hole is very small. When all the A forced to go out, you find it, they will go very fast. Okay, so that means P is a high speed, Q is a normal speed. So P you create become high speed means this part the pressure must be very low. Okay, pressure very low means the water easy to push up. Q is a higher pressure compared to the P, so that means the water not easy to lift up. So that means later, sure the question will call you to label. Okay, now we answer the number 1 first. Okay, now the level color water in the U tube are the same before the A flow. Can you compare the speed of the A at the P and Q? Okay, from this one diagram. So that means we know the speed of the P must be higher than the Q. Okay, then we continue to mark. They want you to mark the level. P high speed, low pressure. So this one, the level must be higher. This one, the level must be lower. Okay, let's check. Okay, how many lower, how many higher is up to you. Important you show the differences. Okay, so the chapter 3 is finished. Then we need to go is a chapter 4. There's a heat. Okay, let's see the first question. Okay, they show about the one of the beaker. Inside, they got hot water. Okay, then after that, the thermometer put inside the hot water. Now they ask you, name one type of the liquid they use in thermometer. Normally, we use is a mercury. Okay, number 2, you need to give one of the reason for the answer in the 1, why we using mercury. So from here, you need to state about the characteristic for the mercury. So we got so many. First one, there's a opaque. Number 2, there's a not stick to the grass. Okay, number 3, there's a high boiling point. We got so more extra, is it? So they just give one only. Okay, B1, complete the following sentence by tick the correct answer. Now the temperature of water is taken when the liquid in the thermometer. Okay, what situation we need to take the readings? Okay, normally is stop to expanding or you start to expanding. So how we go to measure the reading of the temperature of water? So normally we wait it until stop expanding, then we go to take the readings. Okay, when they start to move, we cannot adjust anything. So until they stop, then we go to take the readings. Okay, name the physics principle that involved in 1B1. So 1B1 is related with the stop expanding. So what situation they will stop expanding? When the both temperature become equal. That means the water temperature and thermometer temperature become the same. Then they will stop. So this one principle is thermal equilibrium. Okay, the question number 2, there's a 8.1. They show about the uncalibrate the mercury thermometer they place in the beaker containing the ice cube and the water at 0 degrees Celsius. The length of the mercury column is 6. So I can say 6 cm is L0. Okay, when the length, the thermometer is 0 degrees Celsius. So 8.2, the length of the mercury, they become 20 cm. When the ice cube and water is bigger are boiled until 100. So I can say 20 cm is L100. Okay, now we continue. Okay, so from here, continue with the 8.3. 8.3, now the length of the mercury, that's a 16 cm. when the thermometer they put inside one of the hot liquid temperature, then we do know what is the degree Celsius. So from here we need to apply the formula how to find final temperature is how many. When you put inside another hot water, then the length they show you 16 cm. Okay, we start question A. Complete the following sentence by tick correct. Okay, temperature is a base quantities. Okay, B1. Based on diagram 8.1 and 8.2, you need to determine the difference in the length of mercury column. Okay, different, that means we just minus. Okay, we take the 20 minus the 6, so the difference is a 14 cm. Okay, based on 8.3, and also the answer in the 14, you need to calculate the temperature of the data when they put inside the hot water. So remember the equation. You want to find the new temperature, you need to using L data minus the L0. Okay, and over the L100 minus the L0. So I show you data equal L data. That's a 16 minus L0. Okay, bottom is a L100 minus L0. Then multiply with the 100 degrees Celsius. So finally, I know when 16 cm, the temperature is a 71.4 degrees Celsius. Okay, now, to continue the question, what will happen to the boiling point of the water if the boil on the top of the mountain? So that means you bring whole things, you go to the mountain, you find it, how about the boiling point? So you need to know, mountain, the atmospheric pressure should be the lower. So should be lower means that easy to boil the water. That means they take short time, they can boil the water already. So you see the answer, the boiling point must be decreases. Okay, let's see the C. That's a 8.4. They show the design of the thermometer we can use to determine the body temperature of the patient. So from here they show them several characteristics of the different for the thermometer. Okay, let's check it. Okay, now the table they give you PQRS. Okay, now the range 0, 100, 30, 45. Then two types only. Diameter is the capillary tube. There's a small and big. Okay, accuracy 0.1 and 1. Okay, from here, before we go to answer the question, okay, you want to increase the sensitivity of the thermometer. First one, you must using the thin wall bulb. The bulb must be thin. Another one, the diameter of the capillary tube must be narrow. Okay, or you say smaller. That one is increase the sensitivity. Okay, if you're more sensitive, that means accuracy normally must be the smaller. Okay, so this one is how we increase the sensitivity. Okay, now you need to choose the suitable range of the thermometer to measure the body temperature. So this one is a keyword, the body of the patient temperature. So body of temperature of the patient, we no need until 100 because we just 30 something only. So maximum until 36.9. Okay, if your fever is just 40, 41. So that means we need the range is 30 to 45, then we need enough. Okay, so we say 30 to 45. So what's the reason? That's a human temperature. So that's what we put there. That's a normal temperature for the human. Okay, diameter, we choose the narrow one. Okay, small. Reason, we want to increase the sensitivity. Okay, accuracy, we must choose about the small one. So from here, the accuracy must be 0.1 degrees Celsius. Okay, so from here, reason why I choose the small accuracy, because they can more accurate. Okay, now last one, you need to choose which one is the most suitable. So from here, I choose the answer should be the Q. Okay. Okay, then we continue with the question number 3. They show two blocks, P and Q, have the same mass. They are immersed in the boiling water. Boiling water is a keyword. So understood, boiling water is how many? 100 degrees Celsius, is it? And also the keyword is for long time. Long time means these two, P and Q, they might absorb all the heat already. So if I say thermal equilibrium achieved, P and Q also is 100 degrees Celsius. After that, they transfer into the beaker X and also the beaker Y. Okay, now they give you the info. The mass of the water in the XY is constant 0.25, both also same, and the initial temperature of the water in each beaker is the same. When starting, the temperature is the same. Okay, they give you specific heat capacity for P, Q, and also the water. Specific heat capacity for the P is 900, for the Q is 390. So P should be the higher than the Q. So we're going to see explain about the characteristic first. Okay, 900 high specific capacity means that will take long time to absorb the heat. Okay, then 390 means you are low. Low, that means you are faster to heat up. For this question, they already say it's long time. If long time, that means both P and Q will absorb the heat until thermal equilibrium. So now P and Q, which one will absorb more heat? Sure, it's a P, because you stay for a long time already. And also there's a high specific heat capacity. That means they will store more heat inside the block. Q, because you're faster to heat up. So you just keep a little bit heat only, because you heat up already what? Okay, so now we go to answer the question. Okay, state the initial temperature of the block. So initial temperature of the block is 100, because you are in boiling water. Okay, why is the final temperature of the water in the beaker X higher than the beaker Y? X is a P, block P put inside the X. Okay, I told you just now, because there's a high specific capacity, that means that it will release more heat to the water. Okay, high specific capacity of the P, so they will release more heat. Okay, for B, calculate the raise in temperature of the water in the beaker Y if the Q release 8,400 joule of the heat energy. So this one we must relate it with the Q equal MC data. So the question already provided the total energy. M is for the mass of the water. Then the specific heat for the water also. Then the temperature up is how many, then we don't know. So we just show the formula. 8,400 equal to mass of the water. Then density of the water. Then this one is a changes, or you say rises of the temperature is how many. So from here I get it, there's a 8 degrees Celsius. So that means when the block Q put inside the water, they will increase the temperature until 8 degrees Celsius. Okay, question number 4. Okay, this one they show about the baby bottle. They fill with 0.05 kg of the hot water. Now the hot water in the bottle then will mix with the 0.3 kg cool water to prepare the milk for the baby. Now the temperature of the hot water and cool water are shown in the water dispenser. Okay, now the specific for the water also provided. Okay, now we see the dispenser. For the hot water is 90 degrees Celsius. For the cool water is 30. Okay, so from here they ask you what means of specific capacity. For this one, please, you need to memorize. Okay, there must 1 kg of the mass of the object and also 1 degree Celsius. Okay, let's see here. Heat required to change the temperature. Okay, 1 kg mass. Okay, 1 kg mass of the material by 1 degree Celsius. So you must say the heat required. Number 2, you want to change the temperature. Okay, for what? For 1 kg mass substance by 1 degree Celsius. So you need to mention 3 physical quantities: heat, mass, and also temperature. Okay, now we need to calculate the final temperature for the mixtures. Okay, final temperature of the mixtures, that means we need to using the formula MC data equal MC data. So from here I show. Okay, first one, MC data. The first M is how many water? Hot water, 0.05. Okay, C is the same because both is the water. So C we can cancel to each other. Okay, data is a changes temperature. So final temperature sure less than 90. Agree or not? Because your hot water mixed with the cool water, final temperature sure less than 90. So I take the 90 minus the data. Okay, equal, because finally equilibrium. So we can put the equal here. 0.3 is a cool water. So final temperature sure higher than cool water. So we take the data minus 30. both data is the same thing. Okay, after I do the calculation, okay, this one you can solve by using your calculator. Okay, I get it. The situation is 270 equals 7 data. Okay, finally, I need to find out what is the data. So I need to take 270 over 7. So from it, I get 38.6 degrees Celsius. So this one is the final temperature of the milk after they mix. Okay, now we go to C. The milk is given to a baby who drinks only half. Okay, what will happen to the temperature of the leftover milk in the bottle after a few hours? Sure, the temperature will drop, is it? So why they will drop? Because they lost. Okay, so decreases because the heat lost to the surroundings. Okay, now we go to suggest what you need to do. You want to make the milk to keep warm for longer time. So normally one of the traditional things every time you see, they will put the whole bottle inside one of the cup with the hot water. So that means the hot water, they will cover the surface area of the milk. So after that, they will keep for a longer time. Okay, they show you the readings. Put the bottle into a cup with the hot water. So you want to prevent the heat loss. Okay, so 1 mark is for the where you want to put. Number 2, why you put, because you want to prevent the heat loss. Okay, question number 5, they show you 2 diagrams. One is a clay pot, another one is a copper pot. Okay, specific capacity also provided. This one using 900, this one using 390. Then the mass for the clay pot is 3.5. Then the copper pot is 2.5. Okay, so depends the question what they want. Okay, so I know the clay pot, they take a longer time to heat up because the high specific capacity. Okay, this one will faster. Okay, but if you say you want the food is more soft and after that is more nice, okay, normally they're using the clay pot because they can keep all the heat inside the pot. That means you can make the food is softer compared to the copper. If you say you want to cook the food become faster to heat up, you want faster to take out, that one must be copper pot because they're easy to heat up the food. Okay, now it depends the question. Based on table 8, you need to state the suitable characteristic of the pot if it is to use to cooking something rapidly. So rapidly means faster. So faster, then we understood lah which one we need to use. Give the reason and also the suitable characteristic. Okay, first one, material for making the pot must be copper because you want faster. So we can say there's a copper. Okay, what's the reason? Reason sure is a low specific heat capacity. Okay, so material to making the handle of the pot. So normally the handle of the pot must be high specific heat capacity material because you want to hold it, is it? You hold it, that means you don't want to faster to heat up. So we're using high specific heat capacity material. Reason, heat up slowly. Okay, do not heat up fast. Okay, let's see, heat up slow. Okay, mass of the pot. Normally, we need the lighter one because you're easy to carry, is it? Easy to hold it. So from here, the mass must be low mass. Reason, lighter, easy to carry. Okay, for the question B, the pot are heated by using the electric hot plate. The power is 800 watts. Okay, based on your info for the table 8, you need to calculate the time taken to achieve by the temperature rise until 90 degrees Celsius. So one is a clay pot, one is a copper. So when the question provided the power, normally we use PT. PT equal MC data. So the question they want to find out time taken. Time taken for the 2 pot. Okay, now we go and apply the formula. So I need to show the T now is a 354.38 seconds. Okay, now we go and check the copper pot. 800 multiplied with the T, 2.5, 390, 90. So I get it. The time taken for the copper pot just 109.69 seconds. So that means which one faster? Sure, it's a copper pot become faster. Okay, now they ask determine the most suitable pot we need to use for the safest to handle and also can be heated shorter period. So from here we choose there's a copper pot. Okay, so this one is our discussion about the structure question. Then the following I will continue give you more about the sample of the trial exam SPM and also the SPM past year question discussion. So hope you can like it and also share to your friends. If you like, you can subscribe it. I will keep to do the new video. Thank you for your watching.